Hello and welcome to today's video. In the last tutorial we learned how to multiply each value in a list using a for loop. Today we are given a similar problem, however we are given a list by a friend, and this list does not only contain numbers. This time we want to add 2 to each number. We have 2 integers, a string, a float and a list. We want to add 2 to all numbers and put them in a new list that only contains numbers. So we can try the same thing we did last time. We create a new empty list, then we loop through each value in our list, we add 2 to each value and append the result to our new empty list. Let's execute this script with the run file button and see what happens. Now this gives us a pretty long and confusing error message, but the last part is the important one. Here we see that we got a type error. The type error was raised because of line 12, where we try to perform 2 plus value. The problem is the plus operation, and specifically the type error tells us must be string, not int. The int is the 2, and Python tells us that this 2 should be a string for this operation to work. As we learned in video number 2, we cannot add an integer to a string, but we can add a string to a string without problem. And that is precisely what Python is complaining about in this error. So probably the string in our list is making us problems, and we can confirm this by looking at new list. Our loop fills up new list, but when the error occurs, the script stops, so new list can tell us how far the loop got. We see that there are 2 numbers in new list, so our loop worked fine on the first 2 numbers, but as we suspected, there are no more values, which means that the error occurred at the 3rd element of my list, which is the string. Now let's try to replicate that error and try to add 2 to Jeff. And what do you know? We get precisely the same error message. This might sound weird, but I like error messages in Python, because compared to other languages, these error messages are actually useful most of the time, especially this one. Not only does it tell us the error, but it even suggests a fix for us. We are told that this 2 must be a string, so let's try to convert 2 to a string. Now we are adding 2 strings as we did in video number 2, which just joins both of them. Now this was quite lengthy, but I wanted to talk you through understanding an error message and also nail down one problem with lists. The fact that a list can hold any value makes them very flexible, but it also causes problems because we have no good way of knowing what is in a list. To know what kind of objects a list contains, we have to look at each individual value. What does that mean in our case? If we want to perform an operation that makes sense only for numbers, we have to check that the value we are currently working with is actually a number. The tool we need for this is called if statement. Like loops, if statements also span multiple lines. The header contains the if keyword followed by a Boolean expression. We then indent the code that is part of the if statement to the right, just like we did with loops. For now, we will just pass, which literally means do nothing. We can also introduce an optional else condition that is run in case the if condition is false. In summary, the if statement does something only if the condition is true. Should the condition be false, it can do something else instead. Now we have to use an if statement in our for loop. Before we add 2 to value, we have to make sure that our value is of type int. So our if condition is that the type of our current value has to be equal to int. When that condition is met, we can take our value plus 2 and append it. If it is not true, we simply do nothing. Since the else part is optional and we are doing nothing there, I could leave it out, but this time I will leave it in for clarity. Let's execute this script and see what happens. Now we got rid of the error message, but there is another problem. Only the first 2 numbers were added to the list, although 10.0 clearly is a number. The problem is that 10.0 is a floating point number and not an integer. Let's take a look at the Boolean equality operator and what it exactly does at each value. For the first value in our list, type equals int returns true, which makes sense since 5 clearly is an integer. The same goes for the second value in our list. Now the third value, the equality operator returns false, since Jeff is not an integer but a string. That means that the code under our if condition is skipped for this value, and this is how we avoid our previous error. For the fourth value, which is 10.0, the equality operator also returns false, because it is a float, not an int. Therefore 10.0 is also skipped, but we would like to include it since it is a number. So how do we fix this? Well, since 10.0 is a float, the equality operator returns true if we compare its type against the float type. Therefore, a quick fix is to include a new keyword in our Boolean expression. That keyword is called OR. The OR keyword returns true if either of its sides are true. So if we use 10.0 in this expression, it will return true, because the right part around the OR keyword is true. We should also quickly check what happens when we pass our string to this expression, since it is important that it is skipped. As we hoped, we get false for our string, since it is neither an int nor a float. Now finally, we simply have to introduce this slightly more complicated expression to the if condition in our for loop. Let's execute this script to make sure it works. Now our loop is doing exactly what we want. This was our first video about if statements, but we also learned new things about Boolean expressions, which makes sense because if statements and Boolean expressions are closely related. While if statements allow us to check for conditions, Booleans allow us to define those conditions. The equality operator we have seen is not the only Boolean operator. There are many more and they will get their own video soon. With for loops and if statements, we have learned about Python's most important control flow tools. Control flow is a very general term and it simply means that we are able to take control of the order in which the lines of our code are executed. Loops give us the ability to repeat certain lines of code, and if statements give us the ability to skip certain lines of code depending on some conditions we can define. In the next video, we will learn about another control flow tool called the while loop. We will also write our first small program that takes input from the user and puts it into a list. I hope you will join me for that, and I see you then.